All right, we are back. We are game 2005 in the fall 2017 semester. We are week 3, part 2 of our broadcast. We're still talking about chain rule and integrals, okay? We've just talked about indefinite integrals or antiderivatives, same thing, right? And we've talked about the chain rule really briefly. That's what we talked about in the last video, right? Or the last part of the lecture. Now we're going to get more into integrals. We've talked about antiderivatives being this idea of adding c to it, because when we go backwards, we don't know what the constant's going to be, what it was before we got there, right? Sometimes you'll be given a constant. You'll be given the constant, right? And usually it'll be like you start with this because you've added this much displacement. If you want to find, for example, if this was the velocity function, right, as an example, right? And I said that I want you to find the antiderivative to find the position function, but you started at a distance of 3 kilometers. Started at a distance of 3 kilometers. That's the plus c. See? So I'm finding that this is the position function. And if I said you're starting at a distance of 3 kilometers away from the origin, that's the initial displacement, that's your plus 3. Yes? Multiply it by 2? Okay. Yeah, I would. Yeah, so because remember, c is just, well, c is still a constant. Whatever c, it would be 2c, right? And we're not talking c as in the speed of light in a vacuum, okay? C is something. We don't know, some value, that an original value. All right, let's keep going. So for more complicated, we use some different kind of properties. And this idea of linearity, right, of antiderivatives. So again, when it comes to this, some more complex value, suppose that f and g are antiderivatives of f and g respectively, and k is any constant, then kf is an antiderivative of kf, right? K times capital F is the antiderivative of kf. Notice that I'm taking the constant out. So if I have to talk, kind of figure out if I have a constant that I'm multiplying by the whole derivative, right? If I got a constant times a derivative and I want to find the antiderivative, I take the constant out just like I normally would, and that's how I get the antiderivative, okay? Also, f plus g is an antiderivative of capital F, capital G. So the original function f and original function g, adding them together, is an antiderivative of the derivative of f plus the derivative of g, right? Which makes sense, right? So this is the idea that the constant, remember the whole constant rule, take the constant out when we do a derivative, and the addition and subtraction rule, this is what this is really saying, okay? And sometimes you need to figure things out this way. All right, let's see if we can do a couple more, or one more. If I want to find the antiderivative of this value, what do I do? And again, what I would do is, for those people who are paying attention for the PowerPoint presentation thing, I want to go insert an equation. I'm showing you how to produce more elegant looking equations without writing them by hand. Although for your assignment, when you get it, I'm going to allow that you write it by hand and take a picture of it, upload the picture up on Blackboard. I'll be okay with that too, as long as it's legible. If I cannot read your writing, remember, you're going to do it with a partner. Make sure the person who writes neater, right, is the person who you take a picture of. In this class. If everyone writes bad, please type it, okay? And I'm telling you how to type it with PowerPoint or Word. You have this capability. Even Excel allows you to have the ability to add in the equation, so you don't have to write it. So why am I telling you this in advance? Because the assignment might be easy to calculate by hand, but then writing it out might be another step. So please give yourself time to write it out when you upload it to Blackboard, all right, somehow. All right, so I want to find the original function f. So I want to find f of x. That's the first thing I write down. I write down f of x. Once you get this, f prime at x, I want to find f of x, right? That's what I'm finding in the antiderivative. And I want to look at the next value. So I want to find the antiderivative of 2x to the 8. Uh-oh, that's a weird value. What am I going to do first? I'm going to write that term first, like x to the 9, right? And I get the original coefficient over the new value and I'm multiplying it by, right? And this is my way of doing it, 2 over 9. Does that make sense? If I multiply this by 9 to the 9, right? 9 times 2 is 18 over 9 is 2, x to the 8. That would be the derivative, right? Does that make sense? See how I did that? I took the original coefficient and divided it by the new exponent. I divided by the new exponent, right? Original coefficient divided by the new exponent multiplied by x to the new exponent. All right, that's how it worked out. I will write this out in class. Don't worry. In our lab, I'll write it out so you guys can see. All right, cool. Now I got the next term. So I need plus something x squared, right? So I write the next part out. So here's my equation, right? I want to write x squared. I want to write that in. So x to the 2. There's x squared. Okay, cool. I know that I'm going to take the original term, the original coefficient 3, over 2 and put it in front. So it's going to be 3 over 2 in front. Do you see that? It's 2 over 2 times 2, right? Or 2 times 3 is 6, over 2 is 3, right? Plus 1x, which can be simply written as x. Am I done? No. I need to add the c to it. That's x plus c. You see that? A more complicated one, right? You might get something like this on a test. No problem. But that's not that complicated, right? Because we're just moving up the chain, right? It's a little bit more complicated. I'm not going to do the next one with us. I'll do it in the lab because I need to move on. But you see that? For those people who are watching the video, what's a way to check? Online tools, right? Like I told you, right? When I give you an assignment, you're going to go up here and say integral calculator, right? And you're going to put in there this one, Symbol Lab, right? Symbol Lab has the ones that we want to use as long as they're available. Notice that I have these 2 integrals here, but they give space. This is the funny S that I talked about. This is the integral symbol, right? There's 2 types. There's this type, which is the definite integral, which we haven't talked about yet, and this type, which is the integral, right? The antiderivative or the integral. This is the indefinite integral when you see this, because you don't know what the values are. So if I take the definite integral, let's just kind of take that out and let's get rid of this part. Let's just get rid of this, write this in properly. The integral, and notice I have d of dx. That's the other way to write antiderivative, right? I want to find the integral of a certain value. Let's go back to the equation, 2x to the 8 plus 3x plus 1. So I'm going to write that down. So 2x to the 8, right, plus 3x plus 1. I want to find the antiderivative or the integral, that's what we say, of this equation, dx with respect to x. That's what dx means. So I want to find the antiderivative or the integral. I'm just using the language again and again so you hear it, right? If you hear it in some kind of problem format, right? Find the antiderivative or the integral of 2x to the 8 plus 3x plus 1 with respect to x. That's what dx is with respect to x, okay? Okay, so cool. Let's do that. So if I go back over and see if I've made the right choices, I press go, right? And it gives you some steps. And notice that we have something very similar, right? So 2x 8 plus 3x plus 1 dx is equal to 2 over 9 x to the 9 plus 3 over 2 x to the 2 plus x plus c, which is exactly what we got. And it gives you steps, which is really kind of cool. So here's the sum rule, right? Because some sum one function times another. Notice we have 3 different terms, right? And I can get the integrals separately. I can do the integrals of each of the terms separately. So the antiderivative, if it makes it easier for you, do it for each of the terms separately and then add them together, right? Or subtract them or whatever the terms will be, right? And it helps you figure out this whole thing. Notice that it found it in 3 steps here. So it said, well, 2x to the 8 must be, 2 over 9 to the 9, x to the 9, right? That's how I figured this out. And it figured out each of the terms separately and then added them all together. And then, of course, it added c at the end because it's some constant we're adding at the end to get to the original function. Guys and girls, I think it's a great little tool. Lots of online tools to check your work, right? So when I give you the assignment, check your work and figure out what the answer is. But please don't copy it. find it out by yourself. Try it out by yourself first. Check to see if you're right. And if you're right, that's what you hand in your solution. Because if you just give me this, yeah, okay, you'll get perfect on the assignment. But then when it comes to the test, you'll fail, right? And that's not good. The tests are worth more than the assignments, if you notice, right? So it won't help you. Try and figure out how to do stuff. And there's some really good thing is it also graphs it out for you. So it shows you this curve. This is the curve, right? Which I like it. I like it a lot. And it probably even gives you some problem questions you can try out yourself. Now this when you see this form here, this is not an indefinite integral. This is a definite integral because I go from some value 0 to some value pi, right? And how do I figure this one? Actually, it's quite easy. We're going to talk about it in a second. All right. And here are some useful antiderivative formulas that I put on here if you actually look at the PowerPoint. For example, if I have, if I'm looking at lowercase f and I want to move to capital F, the original equation, it's kind of written in a weird form. But if I go from lowercase f, which is the derivative, to the original function, and if I have some x to the n, right, then the result is x to the n plus 1 over n plus 1. And that's how I find it. As long as n, where n cannot be minus 1, because any exponent to the minus 1 would be undefined and some kind of imaginary number, right? And the same thing goes here. Sine x is minus cos x, right? Because we're going backwards. And I've given you some identities here. E to the x, of course, is just e to the x again, going backwards, up and back. Doesn't matter how you do it, forward and back, right? So if you're going to get these equations on your test, you need to know which one to use. So if you see one like 1 over the root 1 minus x squared, you're going to see that the antiderivative is sine to the negative 1x, which is kind of a weird format, but that's the answer, right? So I'll give you this. This is ln of x, or the natural log of x. That's what this is called. So if I see something 1 over x, then the antiderivative is the natural log of x. All right? Natural log, you guys maybe have not done the logarithmic function before. And will I give you anything with ln in there? Probably not. That's the answer. I'm not going to give you something that is, probably something you won't use. All right, so some antiderivatives, and we've given you some examples of more examples for antiderivatives, which I'm going to cover in lab, right? But here's one. 8 over x is like 8 times 1 over x. And if I was ever going to give you this, which I'm probably not going to, you can see that the derivative of 1 over x is ln x, or the antiderivative is ln x. So this term would be ln x, or the natural log of x, people say as well, right? Minus, and this is a weird thing, something over 1x squared. Well, look, there's 1 root of 1 minus x squared, which is sine minus 1x. So this is 3 times, 3 is a constant, times sine of negative 1x, right? That would be the answer, right? So would I ever give you this kind of thing? Hell no, but I want you to be able to figure it out anyway, given what I've given you already, all right? Would I give you this on an assignment? Maybe, because then you have chances to check it out and figure out how to do it, because an assignment gives you more time to figure out the answer. On the test, you have no time. So I can't give you something like that on a test in our case. And I've also given you some additional integral rules. So x to the n is actually nx, n to the n minus 1, right? The integral of x to the n, here's the opposite. This is exactly what I was telling you, how I did the integral. This is the rule that I use, right? It's like the anti-power rule, anti-power, right? Which is like kind of saying, well, if you have something to the n, x to the n, if you want to find the integral of x to the n, this is the derivative, right? Then the integral would be x to the n plus 1 over n plus 1, right? Which makes sense. Plus c, of course, and so on. Okay, those are some rules you can follow. I'm going to give you all this on the test, right? By the way, if I don't include questions that need these things, they won't appear on the test. Right? So if your cheat sheet doesn't include them, you don't need them. Chances are. All right? I'm not going to try and put extra stuff to confuse you or obscure the what I want you to use. All right?
You get a cheat sheet beforehand?
Yeah. I don't know about a week before, but I'll give you on the test. You'll get a cheat sheet. So if I give you a week before, then you'll know what's on the test, right? you can integrate, or you can derive, right, what's going to be on the test from the cheat sheet, right? The cheat sheet is the derivative of the test, right? No, the answer is no. You'll get it on the test. All right. Nice try. I like your thinking, Logan. Okay, let's go back here. And here's some more. Here's a reciprocal rule, right? Where which is what I said earlier, which is the integral of 1 over x is the natural log of x plus c. All right. When I don't expect that you're going to see too many of those in the test. Same thing with the derivative, or sorry, the antiderivative, or the integral of ln of x, the natural log of x, is x ln x minus x plus c. I'm not going to probably give you these. I'm going to probably give you the basic stuff, cos and sine, that kind of stuff on a test, because you should be able to figure those out very quickly, right? All I want you to be able to do is, on a test, derive and integrate, right? I want to be able to, those two basic things, of course, limits, derivatives, and integration in the basic format. And there might be, just because you mentioned it, right? There might be a bonus question where you have some kind of other weird thing together that's natural log. And if I did that, then I would put it in there. No easy bonus. I'd probably give you some easy questions. The format of the test is probably going to be like this. Some easy questions that are easy to see, x squared, derivative of x squared might be on the test, right? What is that? So you get a mark. And then some harder ones, right, in one page. So a bunch of derivatives, find the derivative, right? And a bunch of them in the page where you have some kind of multiple choice or the answer with the derivative, right? And there might be some more difficult ones where you have to use the power rule, the quotient rule, the product rule all together, right? And the chain rule. And that might be the one that's worth a few more marks, right? All right, let's keep going because we're running out of time here. All right, so we can also figure this out. If I say that f prime of x is equal to x squared and f prime at 0 is equal to 5, find f of x. How do I figure this out? F prime at 0 is equal to 5. So this kind of idea is like an application of the antiderivative, right? So if we know that f prime of x is x squared, then what is the original equation, right? Well, we would say that x2 plus 1 is 3, x to the 3, right? And then we take the original coefficient 1 over 3, right? So it'd be 1 over 3. So x over 3 to the 3 would be the original equation. Now we plug in. We know that f at 0 is 5, right? F at 0 is 5. Therefore, we can find what c is, right? Because if that would be c, then c would be 5, would it not? Think about it. F at 0 means it would wipe out all the x terms, anything with an x in it, right? So if we know that the original f at 0 is equal to 5, then we know c must be equal to 5, which means you could figure out what c is, right? Given that value, given x at 0 is equal to 5. You see that? And if you don't, we'll talk about it at lab, right? So you can actually find two things. You can find f of x, which is, again, x over 3, x to the 3, right? Plus 5. That would be it, because the 5 would be the c. Because we know that x to the 0, or f of x to the, f to the 0, is 5, right? Yeah, because remember we say that the original equation is 1x to the 2. You imaginary 1 there, right? Yep. 1x to the 2. And then we need to go x to the 3 for the original equation, right? Something to the 3, or x to the 3. And then we take 1, the original coefficient, over the new exponent. 1 over 3 times x to the 3 would be your original f equation, right? The antiderivative, right? And then if you plugged in 0 there, right? And you said that, well, f at 0 is 5, you know that c must be 5 because you're adding c to it, right? Does that make sense? You're adding c to it, and f at 0, if you put 0 in and substitute 0 where the x's are, right? It wipes out all the x terms. X to the 5 would be now just 0, plus some c. But when x is 0, then c must be equal to 5, right? And I'll write that down in the lab if you guys don't see it later on. This is the way to figure out what the c value is. Here's another one, right? You have some derivative x5 plus 3 times root of x over x to the 3. How would you find the antiderivative of this? What's the approach you would take? Well, we got a couple of things going on here, right? We have something over something. It's almost like I've got the quotient rule happening, right? It's almost like I can actually parse this, if you think about it, into two separate parts, right? There is something on the top multiplied by the inverse of something on the bottom, 1 over x, right? Remember that whole natural log thing? You'd be able to get something out of there. If you were to derive to get the antiderivative, you probably use the quotient rule to get here, right? That's what you probably did, right? But we'll talk about how to do this in lab, right? And then, of course, you're plugging in 1, where 1 is 1/3, and then you can find c when you do that. All right. Something called the fundamental theorem of calculus defines the idea of the definite integral. Okay, so we talked about up until now indefinite integrals, right? Where we don't know what c is unless you're given some kind of extra information, like I just gave you. Well, then that f at 0 is equal to 5. That you can probably figure out c, and we'll talk about that in lab more, right? But what about when you have some kind of values that you start off with? So, for example, I want to find the integral, right? The definite integral, where you put these. This is the syntax. You put the number that you're going from to the number that you're going to, the range. This is the range from 0 to 5. That's how an integral from 0 to 5 for all values t. That's what we're saying here, right? Of the via t. Okay, that's what we're doing here. So how do you figure this out? You take the final value, the final range, 5, and you subtract the antiderivative of, so you take the antiderivative with 5 plugged in, and then you take the antiderivative with 0 plugged in. You take the higher range and you subtract the lower range. Okay. So let's take a look at this, right? So again, if g at x is equal to some range between a and x, the integral of a and x, then we can say that f at t with respect to t, right, then g prime at x, right, is equal to f of x. Now, and the way you figure it out is you take the original equation, right, at b, and you subtract the original equation with the value of a plugged in. You're just substituting b or a, right? And then you find the total. Now, this is really great for finding the area under the curve, right? Where I know that I want to travel from some value to some other value. I've got, I'm going from this value to this value, that kind of thing. I have a definite number under the curve that I'm looking at. I'm not finding all values of x. I'm only finding certain values of x that I want to plug in from 0 to 5, some range, right? Okay, this is the more difficult stuff, so please pay attention. So let's suppose I want to use this one. If I have this symbology, what I'm looking at is saying this. First of all, I want to find the antiderivative. What's the antiderivative of x squared? Let me just plug in the equation formula here. So here's the equation formula. Yay. Okay, I'm going to bring this up here, and I want you to help me out. What's the antiderivative? That's the first part you find out. The antiderivative of, or the integral of x squared. Well, we know that we're going to have some value x to the 3, right? So let's try this out again, x to the 3. And we know that 1 is the coefficient in front of this particular thing. So we're going to say, well, it's 1 over 3 that we multiply in front of this one. So 1, oops, let me just put this one in so it works. 1 over 3, right? So that is the antiderivative of x squared. Great. But that's the first part. So the first part is finding the antiderivative of this, right? Now the second part, right? I want to sub in the values of 1 in here instead of things. Let's sub in the value of 1, right? And I want to subtract, right, the value of, let's see if I can do this properly without being completely messed up. Okay, cool. of 0 on the second part. Okay, cool. So this, if you evaluate this piece, you'll get the definite integral between 0 and 1 of x squared. So what I'm actually doing is there's two parts. One, find the antiderivative. You need to show your work, so do this part first. So you'd say something like, you know, the antiderivative of this is this, right? And then what I would do is I want to evaluate the first term, plugging in the upper range, the maximum range, max, right? In this case, it's 1. 1 to the 3 is just 1, so it'd be 1/3, minus something to the 0. What's 0 to the 3? 0, right? So it'd be minus 0, which would be just 1/3. So that would be, the answer would be, in this particular case, it would evaluate to, if you kept evaluating, which would be equal to, sorry, guys, you got to listen instead of talk. I'm hearing talking and you're not listening and you're going to miss this. And then this is kind of a hard part, right? If you've never seen it before, right? It's equal to 1/3. You see that I'm taking the original equation, I'm the original integral, x to the 2, finding the integral for it, which is right here. This is the original equation, right? If I was to take the derivative of this, notice I'm not adding c in this particular case, because this is a definite integral. We only add c when we talk indefinite integrals. And the difference between the two from a notation perspective is you don't have this 0 and 1 on the top. You don't have this notation. If you see that curly s, it looks like an integral with nothing, there's no values, min, max, right? You know it's an indefinite integral and you have to add c in the end, right? If you see this notation, then you don't add c to end. What you're supposed to do is take the first, you take the maximum range, take the antiderivative, plug in the value, the maximum value here, and subtract the lower value here, and then you get some value. Let's try the next one, because I know this one's easy because it's x squared. Let's try this one over here. All right, so I'm just going to take these placeholders so I can make it easy for myself. That's all I'm doing. I'm bringing this down. We're just going to change the equation, right? All right, so we want to find the antiderivative first. So what's the antiderivative of 3x plus 2? Well, we know, okay, we know that it's not going to be x to the 3 anymore. It's going to be x squared. We know that x goes to x squared, so we add that 1. And we know that this is 3, the original coefficient, and then over 2. That's what we're going to put in here. So we have to put that term in front. So 3 over 2. So let's do that, because that's the way we can find out the, you know, the original thing. So 3 over 2 x squared. This is this part, right? The first term, plus the second term, which is just 2x. Okay, so that is this would be almost like your equation f. If I was going to say that this is f prime up here, then this would be f, some f. All right, that would be the original equation. Capital F would be the original equation. That's how we write the original equation, okay? Does that make sense? First of all, the antiderivative is what we need to do here for this part. Okay, cool. Now the next part is we need to do this funky stuff where we take the values at 1, that's the max, and subtract it from the values at -1. So we take this whole equation again, and to find the integral between the two, the definite integral, we wouldn't say that we wouldn't put f. We'd actually copy this whole thing, this 1 to, you know, from 1 to -3, and actually we'd write it in terms of, we'd actually write a line. I can't write it here, but we would write a line. I'm going to do this in lab with you, and then we put 1 and -3 in the bottom, just a line, not an s. That's the notation we'd write. And I can't show you this here. All right, but we plug in the value. So we say something like this. Well, I know that I want to do this twice, so let us put some brackets around the whole thing, because I want to try and do this, minus this again. Okay, I don't mind that. I'll take that, because I don't have to type, right? It's going to get rid of the equals. 1 minus this, but I want to take the maximum value substituted on this side and the minimum value substituted on this side. Right, so let's try that out. So I'm going to say the minimum value, or the maximum value, is 1, right? So I'm going to type 1 in here, right? And then this one would be a -3, because that's the minimum value, right? Tell me that you see this. right? And I'll bring this over here a little bit so you can see more. And this would be a -3 here. Okay. So what I've done is I have to evaluate now. This is only one step. I'm just going to move this up here for now, okay? So I can evaluate. I want to evaluate this. How does this evaluate? Well, 3/2 times 1 is 3/2, right? Because 1 to the 2 is just 1, right? Plus 2, 3/2 plus 2. So that's this part. So let's just write this out. I'm going to go insert equation, right? And I'm going to put in 3/2, right? Because this 3/2 times 1, 3/2 times 1 is just 1. I'm going to put a bracket here because I want to respect the brackets for now, right? We should respect the brackets, right? Plus 2. This is the first part. Minus, let's keep evaluating. 3/2 times -3 to the 2. What's -3 to the 2? 9, right? So 9 times 3 is 27 over 2. Right? So this is 27 over 2. Let's put the brackets just to respect the brackets, right? 27 over 2, right? Plus 2 to the -3, 2 times -3, which is -6. So we just put -6 there. Oops. -6, right? And you kept evaluating this, you would get some answer, right? It could be negative or positive. It doesn't matter, right? And let's take a look at this. Do you see that? I've taken the first, substituted the maximum value, and the second, substitute the maximum value, the minimum value, and then I get the integral, the definite integral between a range of numbers from the minimum to the maximum. Yes, you're asking a question.
How far do we have to go in this?
I want you in this case to keep evaluating. So I mean, you plug it into your calculator, and whatever that would be, right? So this wouldn't be enough for me. This would be like you get 1 mark for this, you get 1 mark for this. You get 1 mark for this, and then the final answer, you get the last mark. So 4 marks, right? Everyone see that? Because the final answer, just plug into your calculator, right? And you find whatever answer that's going to be, right? To figure this out online, what's my time like? 5:24. I'm timing out, guys. So I'm going to show you this part here really quickly. Online, if I was going to figure this out, right, I want to find the definite integral here. So let's do another one. So I will refresh this one. Let's just find the definite integral here. Let's just kill this whole term. I want to find the definite integral between, you can see that it's 1. Oh, is it 1? I did, yeah. It's 1 and -3, right? 1 and -3. That's how we write it. Of, right? 3x plus 2, 3x plus 2. You can see that that's the definite integral. You can do that. And then if I scroll over to the right, oops, I'm just zoomed in here. I can go plus go. And what it's going to do is it's going to show you all the same steps. Now, take a look what it says. The answer is -4. Right now, I'm sure if I added all those things up and figured it out, it would end up being -4, right? But it actually shows you all the steps, if you think about it, right? So compute the indefinite integral, right, first, and then compute the boundaries. That's the second part. So exactly what we said. Notice that I just took away C because I don't care about C. Because I'm calculating the definite integral, I don't care about C, right? And notice when it figured out the boundaries, and I bet you they can break this out into different parts. Here's the steps for this. It's exactly what I told you. It's taken the first one, substituting in a 1, right? Or, yeah, a 1. And then you get the second one, substitute in a -3, and you're going to get a value, some 7 over 2 minus 15 over 2, which is going to actually equate to -4 at the end. All right. So you can always check your work online, and I think it's a great thing about our modern age. We have the best library in the world, right? Interactive library. I'm almost done. I know I'm running over time, but there's quite a lot to handle on this one. This is the last part, and I want to talk about when you have something really complex. Remember we talked about the chain rule? This is the analog of the chain rule for integration, okay? It's called integration by parts. And my friends, I can't save you from this in any way. This is the hardest part of calculus, I would say, right? Because when you look at it, you have all these U's and V's, and what the heck is that U and V stuff, right? We're going to handle it in lab, right? Where I have some integral of U, And then with respect to v, right? Well, that actually equals to, I take the u out, I remove the u, right, which some constant u, right? And then multiply it by v, right, whatever that v is, minus the integral of v with respect to u. How does this work? So let's let dv, d with respect to v, be the most complicated portion of the integrand, is what we say. We call it the integrand, right? And it fits a basic integration formula. This is where you might have to be a little creative. Remember, there's no creativity when it comes to derivatives. You just look at the derivative and you figure out or you look at the original equation to get the derivative. It's pretty simple. You follow derivative rules. Same thing with limits. But when it comes to integrals, there's many ways to get back to the original equation. This is where the creativity comes into play. And if you're not creative, or if you can't simplify, or you don't know what to do first, you're going to leave it blank. You're going to look at it and go, I have no clue, right? So it gives you some basic things here we're going to talk about in lab, but I want you to think of it like this. This is what I want to evaluate. I want to evaluate the integral of x e to the x, all right? What I want to do is I want to apply this idea that x is actually u, and e to the x dx is actually dv, d with respect to v. And once I've done that, right, then what I can do is I can figure out the integral, right? There's different ways of figuring this out. This is what this is showing you, right, where you can actually choose x times e to the x to be u. I can choose u as 1 and dv as x to e to the x dx. You can see that there's different ways of doing this thing. I can choose u and dv to be any of those things. Now, when you look at it, all I'm doing is, it's just like me saying, well, apple is equal to x and orange is equal to e to the x. And how do I get the integral of apple times orange? That's what I'm really saying, where orange is e to the x and apple is x, right? And when you start thinking about that, this is where we can really kind of figure out the integrals of more complex formulas, right? Now notice this is the indefinite integral, which means we added c at the end as well. I've given you some examples here where I've got I'm starting to figure out, that x times e to the x minus e to the x plus c is the answer. And how do I figure that out? Well, I've given you the answer. I'm saying, well, if we assume that u is x and d to the v is e to the x dx, right? And if you plug in these values, right, then what you're actually figuring out is the derivative of the antiderivative of the first, right, or the antiderivative of u, right, is equal to, you put this on the other side, right, is equal to the u times v, so u is x, v is e to the x, right, u times v minus x times e to the x, right, minus, right, the antiderivative of v with respect to u, right? And the antiderivative of v with respect to u is e to the x equates to e to the x. And of course, we have to add c to it because c is a constant we have to get back to. Now, when you look at this, you're going to say, I don't understand a goddamn thing about this, Tom. Why are you saying it? Because we need to use this form in order for us to find the integral or the antiderivative of more complex equations. All right? After this, I've given you some example, which we're going to follow in lab. But for now, I think this is where I want to stop. I know we're running late for lab. Guys, thank you so much for watching and for listening. Remember, I'm going to simplify things in lab.
Before I take off, I'm sorry to bother
you
for 2 seconds here. Got a couple of announcements here for you. Number one, I'd like to introduce myself. I'm Corey Ron.